Hi students, how are you doing today? Welcome to iTTV, and you're watching me, Mr. Joel, your tutor for Mathematics Form 4. Alright, today we have arrived at Lesson 3 of Chapter 2, Quadratic Expressions and Equations. Alright, for today's lesson, we're going to learn how to factorize quadratic expressions. In our previous lesson, we have learned that in order to obtain a single quadratic expression, what you must do is get two linear expressions and expand them, or multiply step by step, term by term, to obtain a quadratic expression in the form of ax squared plus bx plus c. Alright. Factorization of quadratic expressions. What is it actually? Very simple. Factorization is the opposite of expansion. Take a look at the equation below. X multiplied by 2x minus 3, and we have learned this. When you expand x and 2x minus 3, you will get 2x squared minus 3x. Alright, let's look at what is the right and left hand side of this equation. Let's take x and 2x minus 3. Alright, this is actually known as the factorization form of the quadratic expression. Alright, the factorization form of the quadratic expression is when the two linear expressions have yet to be multiplied or expanded to form a quadratic expression. And what about 2x squared minus 3x? This is known as the expanded form of the quadratic expression. And also, it is known as the general or standard form of the quadratic expression. So actually, expansion and factorization is the inverse of one another. Alright, let us take a look at this on the board. Alright guys, in lesson 2, we have learned that in order to obtain one quadratic expression, what you must do is take two linear algebraic expressions. It means that two of them have to have x as the power of 1, and then you apply expansion. Remember that? To get one quadratic expression. So the difference between that and today's lesson is we are going to obtain the two linear algebraic expressions from the quadratic expression. So it's actually the opposite of expansion. And the opposite of expansion is called factorization. So that is basically the difference between expansion and factorization. Alright, so there are a few things to remember when factorization of quadratic expression happens. Alright, let's look at that. Factorization of a quadratic expression means, first, factoring of the expression into the product of its factors. And usually the factors are linear algebraic expressions. Alright, so what does it mean here? So when you have a quadratic expression and you obtain back the two linear expressions, you're actually getting the product of the two linear expressions. And that is the whole idea and the whole purpose of factorization from a quadratic expression. Now, basically, factorization of quadratic expressions can be divided into four categories. Alright, first, ax squared plus bx. Secondly, ax squared plus c. Third, a squared x squared minus b squared. And a very important note to remember is that a, b and c are non-zeros constants. And the final form is ax squared plus bx plus c. Alright guys, listen carefully. So the four types of quadratic expressions here depends. Alright, and it will tell you the linear expression that it will obtain from it. For every type of quadratic expression, there is a method to find back its two linear algebraic expressions. So it's actually not as simple as expansion. But once you remember the four categories, it is possible. Alright, A, B and C are constants and A always cannot be zero. One final reminder. Alright, now, factorization of quadratic expressions. We are going to look at the first form of quadratic expression that needs to be factorized. Remember, when you hear the word factorize, it means from a quadratic expression, make them and separate the quadratic expression back into its two linear expressions. Alright, we have looked at the four general basic categories. The first category is factoring of ax squared plus bx. Alright, always remember, ax squared plus bx is a quadratic expression. You know what a and b stand for. The variable is x. In this factorization, step 1, take out the highest common factor, or HCF, of the terms in the expression. Step 2, place it in front of the brackets. And in step 3, the expression in the bracket is obtained by dividing each term in ax squared plus bx by the highest common factor. Alright, let's look at this example. Factorize completely 3x squared plus 6x. Alright, we're going to move to the board for this. Alright guys, this is type 1. Alright, when you are factoring a quadratic expression in the form of ax squared plus bx. But now, when we are looking at this specific example, a is 3 and b is 6. So it's ax squared plus 6x. This is the first category of quadratic expression. So remember the 3 steps. How are you going to factorize? First step, what is the highest common factor of the quadratic expression? When the highest common factor is mentioned, it can be either the constant or it can be the variable. So 3 and 6, they have a highest common factor of 3. So step 2, we must place the common factors in front and outside of the bracket. But that's not all, because x and x squared, the highest common factor for x and x squared is x. Alright, that is step 2, taking out the highest common factor. To do that, remember, step by step, constant and variable. Place it outside the bracket. And the final step, divide. The quadratic expression, every term has to be divided by the highest common factor. So when 3x squared divides by 3x, you will obtain x. And when 6x is divided by 3x, you will obtain 2. So what have we got here? A quadratic expression has been factorized. Means we have managed to separate it back into its two linear algebraic expressions. And there is always one way to test it back. You can always multiply back or expand the two linear expressions. Will you get back? So you can test and check it by expansion and factorization. Alright, now we will look at the second category of quadratic expression and how to factorize it. Factoring of ax squared plus c. Alright, now a and c are both positive or both negative numbers. In this factorization, step 1, take out the highest common factor, HCF, of the terms in the expression. Step 2, place it in front of the brackets. And step 3, the expression in the bracket is obtained by dividing each term in ax squared plus c by the highest common factor. Alright, let's look at a few examples for factorizing quadratic expressions in category 2, yeah, which is ax squared plus c. Alright, factorize completely. Number 1, 8x squared plus 6, and number 2, negative 81x squared minus 9. So if you look carefully, both of these quadratic expressions are in category 2 because there is an a, which is the constant of the x squared, and c, which is the constant by itself. Alright, so you compare the general form to any given quadratic expression. Alright, let's factorize on the board. Okay, now, ax squared plus c is in our second category. The same 3 steps applies to the first category actually, so it actually makes your work easier. Step 1, remember what is your whole purpose. You're going to get back the 2 linear expressions from this quadratic expression, which has a power of 2 to the x. Let's look at number 1. What is the highest common factor? That is step 1. Alright, 8 and 6, the highest common factor is 2. So immediately put a 2 outside and check. There is an x squared here. This is a constant all by itself, right? So there is no x that belongs to both terms. There is no common factor of any form of variable. So the only common factor is 2, and it happens to be the highest common factor. So once out, placed it in front of the brackets. Now, what is the expression in the bracket? The expression in the bracket is the expression when the whole quadratic expression has been divided by the highest common factor that has been placed outside the bracket. So now divide every term by the highest common factor, okay? So 8x squared divide by 2, you will obtain 4x squared. And follow the sign, positive 6 divided by 2, positive 3. So this is the simplest form of factorization that it can go. Alright, look carefully. How do you check your answer? You check your answer by doing mentally the expanding process. Check. 2 times 4x squared. Will you get back ax squared? Yes. Alright, double check. 2 times 3, 6. Your factorization is perfect. Alright, now for number 2, minus 81x squared minus 9. Okay, so this is still in the second category. If you look back at the form that we have discussed just now, what is the highest common factor? Look at the constant first. Minus 81 minus 9. Alright, you can choose to factorize either positive 9 or negative 9 as your common factor. Okay, in this case, I will factorize negative 9. Okay, so place the highest common factor. There are no more common factors because both don't have any variables. What is the expression in the bracket? It is obtained when you take every term in the quadratic expression divided by that highest common factor. So minus 81x squared divided by minus 9. You will get 9x squared. And negative 9 divided by negative 9, positive 1. Alright, don't leave without checking. Evaluate mentally. Negative 81x squared, negative 9. So what have we done? We have separated both of these quadratic expressions and made it as a product of 2 parts. Here, outside the bracket, and in the bracket. Alright, now we will look at the third category of factorization of quadratic expressions. And it is the factoring of ax squared minus c squared. Alright, for this kind of factorization, be very careful. Let's look at the steps. For step 1, ensure that both the numbers a and c can be written as perfect squares. Step 2, use the fact a square minus b square equals to a plus b, a minus b. Alright, so there are two steps for this kind of factorization. Alright, now let's look at the example that relates to this category. Factorize completely negative 4x squared plus 9. Alright, and this belongs to the third category. Alright guys, be very careful. Alright, in our earlier two, we have looked at 3 steps. Now there are only 2 steps. But a very important identity to remember is the identity of a square minus b square is equals to a minus b multiplied by a plus b. And you have to memorize this useful identity because it will help you to factorize quadratic expressions in this category. Alright, what is this identity all about? It is the reverse. If I have 2 expressions here, when they are multiplied one by one using the expansion process, the final result is a square minus b square. So we're going to use this identity for factorization of quadratic expression in this category. And now, minus 4x squared plus 9. Alright, how to note? Remember the step. Determine if both terms can be written as perfect squares. Yes, it can. Why? Minus 4x squared plus 9 can be rewritten as 9 minus 4x squared. And then what must you do? 9 is actually a perfect square because it is 3 square, a perfect square. And minus 4x square can actually be written as 4 is a perfect square, 2 square, and x square is already a perfect square by itself. Okay? This can be simplified to 3 square minus bracket 2x square. So anytime you see a quadratic expression that is made up of the subtraction of one perfect square from another, you don't have to take out any highest common factor. Immediately use the identity that is written here. In the identity, let's compare. A square is the 3 square, b square is the 2x, and it must always be separated by the minus. If this occurs, the product of factorization is a, which is 3 in this case, minus b, which is 2x in this case, and 3 plus 2x. Alright, so you must remember the identity, and you can always check back your answer to determine if you're right. Expand one by one and see if you get the answer back, the quadratic expression. Alright students, now it's time for our quick test. And it's time to do by yourself. Alright, factorize completely each of the following. Alright, number 1, 8 plus 8x squared. Number 2, 15x squared minus 10. Number 3, minus 10 minus 25x squared. And number 4, 2 minus 18x squared. Alright, now I want you to try by yourself. Alright, I'm sure you have your solutions with you. Alright, for number 1, the answer is 8 bracket 1 plus x squared. For number 2, 5 bracket 3x squared minus 2. For number 3, negative 5 bracket 2 plus 5x squared. And number 4, 2 minus 18x squared will give you 2 bracket 1 minus 3x bracket 1 plus 3x. Alright, now our next exercise, factorize completely each of the following. Alright, come, let's do this together. Alright guys, remember, the key word here is factorize, yeah? Factorize means quadratic expression, splitting it into two linear algebraic expressions. And so far we have covered 3 kinds of categories, alright? So now, they will not tell you whether the quadratic expression belongs to category 1, category 2, and 3. It's up to you to look at the quadratic expression carefully and to identify which category it is basically, and from then on you can see what are the steps, whether it's the 3-step or the 2-step. Alright, now for number 1, factorize 18x minus 10x squared. Alright, is it in category 1, category 2, or category 3? This actually is in category 1. Minus 10x squared plus 18x. So remember, there are 3 steps for this. First of all, what is the highest common factor, or the HCF? Alright, now both have x. Look at 18 and 10. What is the highest common factor for 18 and 10? 2. So put the 2 out, and then look, x and x squared, highest common factor is x. Alright, you have the second step, place it outside the bracket, and third step, determine the expression that remains in the bracket. And how do you obtain it? You get it by taking the expression and dividing each term, there are 2 terms, yeah, and dividing it with the highest common factor. 18x divided by 2x, you will get positive 9. Minus 10x squared divided by 2x minus 5x. Alright, and you can always check back your answer by multiplying back or expanding back the 2 to get back the quadratic expression. So these are the 2 linear expressions in the factorized form. Alright, for number 2, 15x squared plus 5x, also in category 1. Okay, what are the highest common factor? 15 and 5, highest common factor 5. X and x squared, highest common factor is x. So place it outside the bracket. Now, third step, divide each term with the highest common factor. Alright, 15x squared divide by 5x, and you will get a 3x. 5x divided by 5x, you get back 1. Okay, so remember, this is the factorized form. Alright, in 3, which category do you think this expression lies? 1, 2, or 3? Alright, it is actually in category 3. Alright, why? 4. Immediately recognize that 4 is a perfect square, and so is 81. If 2 of the numbers in both of the terms are perfect squares, we have to use the third category, alright, where the involvement of an identity is very important. So now rewrite it as a perfect square. 4 is 2 square and x square, okay, and 81 is 9 square. Okay, so now remember, it must always be minus in the middle. Apply the identity. Okay, so now, if there is a subtraction of one perfect square from another, don't have to take out anything. Immediately use the identity. 1 is a minus, 1 is a plus. Alright, and our final example, number 4. Which category do you think it is? Check. First of all, rewrite it. 121 minus 16x squared. And it's not category 1 or 2. Why? Because 121 is a perfect square, and so is 16. So you must immediately realize if 2 is perfect square, immediately category 3. So write 1 to 1 is 11 square, and 16 is 4 square by x square. Okay, so this part you must be very careful. And lastly, subtraction of a perfect square 4x from another perfect square, which is 1 to 1, written as 11 square. The factorized version is 11 minus 4x, 11 plus 4x. Alright, so actually now we have covered the 3 categories of factorization of quadratic expressions. Alright, so remember, what is factorization? Factorization is a process of getting back the 2 linear expressions from one quadratic expression. Alright, so given a quadratic expression, you must identify quickly, is it in category 1, 2 or 3? Alright, and then apply the necessary steps to obtain. And you can always check it by using the expansion process. Alright students, we have come to the conclusion of lesson 3, alright, of chapter 2. Alright, we'll continue with this lesson in our next one. Thank you very much.